so thank you very much. The title of my presentation is very optimistic, Comply or Die. And the purpose, the thing I'm trying to deliver is regulations and standards affect software architecture more than we would wish it would. Now it's lunchtime, more or less. I understand that lunch is not particularly well-defined time in your offices, but anyway, I would like to start with something light to get you in the good mood. And it's called this emotion, which everybody likes, but few admit. In German, it's called Schadenfreude. And that's the experience of pleasure, joy, or self-satisfaction that comes from learning or witnessing troubles, failures, or humiliation of another. So to that matter, I'd like to give a few examples of troubles, failures, and humiliation. We'll start with a company named Kik. It's not the Kik that you have here. It's an American software company. They started with a messenger app. They got several million users. And then there was the crypto coins. So they started with an ICO. In 2017, TechCrunch basically applauded them on having this high-profile ICO with about $100 million that they were able to raise. Then in July 2018, Kik released their first product, which relates not to the messaging, but to the actual cryptocurrency. They actually released the wallet. That was their first product to release. Then in June 2019, the Securities and Exchange Commission comes over and says, well, you operate on United States soil. What you actually did was issuing shares. You actually raised money without going through the proper procedure. No formal disclosure, no due diligence. We are going to sue you. In August this year, Kik began to fight back. They submitted a 130 pages response to the court. In September, they shut down the messaging app, downsized the workforce. They have only a few people left, and they're now focusing specifically on the tokens. They're trying to fight their way back from where they are now. So, very story. You do an ICO, you are very big, you earn a lot of money. 2 years later, your business is completely gone because you weren't compliant. You didn't go about it in a compliant way. Another case study for Schadenfreude, that will be more like humiliation, less failure. So Robinhood is a brokerage firm. They have it's very, very popular. It's an application, high tech and everything else. So on December 13th, they launch a current account with 3% interest rate, which is unprecedented in the United States. You can get 0.25 and it's on a good day. On 14th of September, that's Friday, right? So Thursday is a launch. Friday, people begin to ask questions. The same day, regulation, SIPC, which was supposed to regulate Robinhood, speaks up and he says, well, nobody spoke with me. So a few days later, early next week, the December 17th, the mass media refers to the entire project as an epic fail because they had to pull back the product. It wasn't compliant. They couldn't operate as a brokerage firm and offer current accounts to their customers. It has to work. It cannot work like that. So that's not the only example, of course, of how regulation can smother a business. And let me show you a couple more shorter ones. This is Nomad Rides, this year's TechCrunch startup competition. I especially like this part. 2 months illegal trial period, had to shut down, but they're legal now, right? Inspires confidence. So another one, Basis. People who decided they want to launch a stable crypto coin, and they want to peg it to a basket of currencies. But then they understood that there are too much regulatory challenges with their business, and they had to go back to venture capitalists and return the money, pay the money back. So by now, You may be asking yourself, well, that's nice, but what does it have to do with software architecture, right? I mean, all bad business decisions, everybody makes them. Well, the thing is, we see a tip of an iceberg here, because we only know about high-profile cases when somebody launches a product to the market and pulls it back, or when a company goes big and then shuts down. But in fact, the waste that's generated constantly by trying the product which then doesn't go live, or by having to redo an entire architecture because it didn't take into account something, this waste, it never goes public. It's always swept under the rug. And the reason for that is inadequate understanding of the business rules, actually, of the table rules in the business. So, the typical thinking of a software architect is that, well, I don't really want to know about it, and I have my technology, I have my best practices. If I stick to that, the software will be good. Well, let me give you one more example. That's like a more practical Schadenfreude, happened very recently. According to the PSD2 directive, every bank in EU, and as I mentioned, we are a bank now, had to expose a test environment for third-party processors to connect to on 13th of March. So we decided that we will have something simple. Credorax is part of the Berlin group, so there wasn't really a choice about which API standard we need to expose. Unlike we operate outside of Poland. In Poland, there is like the Polish API standard for banks. We decided that we will do an in-memory simulator, completely stateless, and it will be good enough. And we will validate, we will make sure that consumers only connect with a valid SSL certificate. We put a little, put it in the Amazon cloud, AWS WAF, some load balancing, 2 different availability zones, so that we can freely upgrade this application without causing any downtime. Seems like a very easy and straightforward thing. So let me tell you first about the PSD2 a little bit. The PSD2 Payment Services Directive 2, is Directive 2015/2366 of the European Commission. It mandates that every bank exposes 3 services: payment initiation, account information, and fund confirmation service. And it also introduces 3 new types of players to the market. So you can apply in every country. You can now apply for a very limited license and be a payment initiation service provider, an account information service provider, or CBPIS card issuer. So this is the law, and we need to expose these services so that these new players can actually come, connect to our systems, and test our APIs. So outside of Poland, this API is the project, the legal framework, so to speak, and the standard framework, regulatory, legal, and standard framework of the API that we needed to implement is more or less like so. There is the actual Payment Services Directive. There is the regulatory technical standard, which was published by the European Banking Authority. There are opinions that they published afterwards. I think there are 3 or 4 clarifications to what they meant in the standard. Consultation papers, actual consultations, guidelines, Q&A tool, which still has, I think, several hundreds of unanswered questions. We are past any deadline on PSD2, and EBA is still answering questions about how to go for it. Then we have the local regulation. That is relatively straightforward because Malta is a small island. We are ahead of curve for PSD2 law. So we just went to the central bank and communicated and spoke with them directly. But in a bigger country, in places like Germany or Bulgaria, for instance, they have local law. It's different, and you have to comply with it as well. Then there is the standard itself. It has an implementation guide. It has a testing guide, which defines which services do you need to expose to third-party processors for testing. And of course, there is the implementer options document and implementer option set of choices, which was delegated to our product team. Because the API standard itself supports a lot of things. We need to only expose things we are actually going to deliver in production. So what happened when we launched and the first third-party processor connected was something like this. The standard says you should use a valid SSL. The architect decided that the web application firewall will take care of the validation of SSL certificates. The regulator said, well, here is the list of root authorities that can, and only then they can issue those certificates for testing and for production. The TPPs simply followed the orders. They went for one of those qualified providers, authorities, got their test certificates and tried to connect. The certificate was not respected by the system, and that's because web application the default WAF that we used in Amazon doesn't allow any manipulation with root certificate authorities. So what happened was, in other words, that the phrase valid SSL certificate has a slightly different meaning for a PSD2 compliant system. And specifically the root CAs, you cannot just take a valid certificate you use for from a generic provider. You have to go for somebody very specific. The architect wasn't aware of this intricacy, so he designed a system which required a major re-engineering of the deployment and the embarrassment and humiliation that we also enjoy. Only this time I was the embarrassed one, so it wasn't particularly pleasant. And of course, we lost some money about it because a small project became a rather big one and very urgent. Because they had to drop everything and do that so that third-party processors can proceed. So with that, let's try something else. Let's imagine that we are in my hometown and it's plus 30 outside and warm and nice and sunny. And we work and we are doing a payment application, a new one. Right? Take an example of how regulation can further make your life more complicated. So let's assume I'm an architect that doesn't really care about regulation. I find a companion, a co-founder, and he handles all the licensing stuff and all the business stuff. I only do software. So he goes to Bank of Israel. He gets us some sort of license. We want to set up, now in Israel there is basically a monopoly. All card payments flow through one single system, a local one, it's called Shva. I want to build a gateway that will compete with it by using a trick, something I know about card payment networks. So today, all domestic terminals are connected to Shva, which routes the transactions to one of the issuer banks for authorization and payment. The solid arrow is a domestic transaction. The dashed arrow is an international transaction. So anything that happens outside of Israel over the non-Israeli card goes from global Visa and MasterCard networks to the same issuer bank. So I want us to do something like that. I'll put a simple gateway. It will capture domestic transactions from Israeli merchants. It will send them through the global network to the issuer banks, bypass Shva completely, and so I can, waltz in, create competition, and become rich. So it's not a difficult application, right? It's just I expose one API, I translate it into two protocols, one for Visa, one for MasterCard, and that's it. It's trivial. It's not trivial, but it's a simple task. So let's assume I do this. I decide that I use Python and Flask, create a RESTful API, a bit of routing logic behind it. I store my transactions in a MySQL database. I create a console for merchants because they will need to see the history of transactions. They will need to be able to issue refunds. I create a console for myself because I'll need to support them, provide them services. I invest into logging. I really I write a lot of logs because I know it will make my life much easier when I go live. I use Docker to deploy it, push it in the cloud, put the sources in the GitHub, and it's very nice and it's very easy. And I'm done in 2 weeks. I'm actually ready to deploy, and since I'm a very good developer, there are no bugs, of course. And suddenly my co-founder tells me that we need to be compliant with something called PCI DSS. PCI DSS is Payment Card Industry Security Standard, and PCI stands for Payment Card Industry. DSS means data security standard. And when taken together means that you now need to work 4 times as hard as you did before. 3 times is not, it's not up to, the slide is not updated, it's actually 4 times. The standard is published by a body called PCI Security Standards Council. It's actually available for free on the internet. You can log in and download it and learn it, if that's your idea of good pastime. There is a family of standards, in fact. Some deal with how you build secure applications. Some deal with how you protect personal identification numbers, how you set up point-to-point encryption, and so on and so forth. The goal, like the overarching idea of all of these standards is to protect these 2 things, as you see on the screen. Is to protect cardholder data, which typically includes card number, cardholder name, expiration date, and some other technical information about a particular card. And to further protect sensitive authentication data, which is even more sensitive than this, and it includes full values of magnetic stripe from the card, the CVV, and pins and pin blocks. So for example, I cannot store the CVV. You need to throw it away after authorization. I cannot store the magnetic stripe. I can store cardholder data, but I have to work really hard to protect it. So by now, because my imaginary co-founder thinks that the PCI DSS is too technical, I have to study the standard. And here's the impact. I use any framework, of course, and everybody uses a framework. That automatically means that I'll have to regularly patch it. Even if I didn't plan to upgrade and to move to a newer version, I will have to do it. I'll have to patch Python. I'll have to bring in new libraries. If there is a security update, then I only have once to do so, or I will not be compliant anymore. Furthermore, I cannot just write code and push it into production. It has to undergo a code review by somebody who had special training, who understands top vulnerabilities, who can identify malicious code, and all of that has to be documented, and I have to be able to show a change control procedure, right? And that's quite a lot for a 2-person startup. Then storage. As I mentioned before, CVVs or full magnetic stripe values cannot be stored. Maybe I've taken it into account, maybe I didn't. There is a requirement to render the PAN, that's primary account number, to render the card number unreadable anywhere it is stored. I can truncate it, I can hash it, I can use some sort of tokenization mechanism, which will cost me a fortune probably. If I use a cryptographic solution, I will also need a secure key management procedure, because I will have to, I don't know, split my keys, dual control, and everything else. Finally, I absolutely must have a retention policy. So I'm forbidden, it's not just not a good idea to store data indefinitely. I actually need to have a well-defined policy, which is very clear on when and how I truncate the database and remove old records. Web console. Merchants will need to log in. If I give them a password, I must support password policies. I must log them out if there are too many failed attempts. And by now, the modern standard, just user password is not enough. I have to provide dual factor authentication with, well, it's pretty standard today as well, but I have to authenticate them with at least 2 out of these 3 factors. Knowledge, possession, and inherence, something they know, something they have, and some sort of biometric thing, it's something they are. So by now, I need to actually probably buy a ready-made solution with a mobile application if I want to use biometrics. Becomes difficult with every step. Then, if there is an admin console, first of all, everything that applies for merchants is also valid here. I cannot display card numbers in my admin console, for example. There is a requirement that any administrative or technical user has minimum required access. So if I ever plan, and I probably want to grow, so I will hire support. And when I hire support, I will have to give them a user that can only see technical stuff, but cannot touch the actual money. And all of that, and user management changes, if I add a user, remove a user, reset a password, unlock an account, all of that must be audited, which brings me to logging. The standard encourages logging but it encourages logging of security-related events, such as an attempt to interfere with logs, pause logs, invalid and valid access attempts. But I cannot write full PAN and other transaction details into any log file in production, which means that my logging system now has to support two types of logging configurations, one for testing, which is full, and one for production, which is partial. It's actually, it's very funny, especially when you need to test and somebody accidentally turns off logging because the system went into production mode. So, next. I cannot simply create a bunch of containers and throw them into the cloud. I have to comply. There is a lot of definitions on how do you build a secure network and how do you separate functions. You only are allowed to have one primary function per server. Your internet-connected machine must reside in a DMZ. Your database must always be inside an internal network. You are not allowed to have any services except the absolutely necessary ones. And finally, all the deployments and the changes in network configuration should also be under a strict procedure and preferably dual control. Even GitHub can have its challenges because there are requirements for secure source control. If I develop a secure application, if I develop application that will be used in production for handling card data, I need to make sure nobody can break in and inject some code into my source repository. GitHub may not qualify for that. I actually didn't check, but absolutely possible. And finally, external access to production must be secured by methods which are, not readily available in the default and the basic cloud configuration. So to summarize, there isn't a technical decision that I made about my solution that I don't have to revisit now. I practically need to redo everything, right? Almost anything that I touched, because of all the regulatory changes found in a standard, which I thought is legally related, but it's actually, it affects my life much more than I thought. All of that required me to re-engineer my application, top to bottom. But okay, let's assume I did it. Card schemes, I have to work with Visa and MasterCard, right? They have their own rules. By card scheme rules, twice a year, I need to update the systems. And everybody who wants to continue working with them must do a relevant update on their systems as well. So in my imaginary scenario, with my luck, next April, they actually make a backward incompatible change, which requires changes on the side of the merchant. But I never told them this may happen. So most of my customers left me. To summarize, compliance and legal questions have profound effect on software architecture, on the deployment, on maintenance, on testing, on working procedures, and on development. Some industries are not regulated, and it's easy. Some industries, especially financial industry, are regulated heavily, and a good architect cannot afford ignoring the regulation. It cannot be delegated to legal teams. Legal are very bad at reading laws. No, seriously. And besides the legal things, they can. It's like, let me rephrase. They can read the law, but they cannot really understand what it means. They're not trained for it. So where company is not only regulated by authority, but it needs to interact with, let's say, a scheme. That's specifically payments. You execute payments by connecting to somebody and telling them what to do. They usually have a set of rules, including security-related rules, including periodic updates that you'll have to comply with. And it's another huge source of changes that you will have to take into account. So, you cannot assume, let's give you an example. There is a protocol called 3D Secure 1.03. It's a simple technology. If you develop something with it, you can assume it will not change because it's already stable. It's been in the market for 10 years. Visa payment protocol, on the other side, changes twice every year. It may be a slight change, it may be a profound change, but if you don't plan for it and you don't allocate capacity, you will get into trouble first time it happens. As I mentioned, Now, it's not an unsurmountable obstacle. You can actually, I mean, once you know how to do it, it's almost like it's easy. The thing is, you need to figure out all the things before you get started and not after you've delivered the first release. So that's it. Thank you very much.